When you're learning about integration by parts, you often see something like x e to the x, and then you're asked to integrate that. But sometimes you're given things that are a little bit harder to work with. So let's take an example of what that might look like. Let's say you're given the integral of e to the x sine x dx, and you want to find what this is, right? So let's take a look. Okay, this doesn't really look like an x, so let's fix that. But this is our function over here, right? We want to go ahead and integrate this. So as you remember, the first thing we want to do is kind of break this up into two products. So of course that's going to be e to the x, and that's going to be sine of x. Now which one is easier to integrate and which one is easier to differentiate? Over here it really doesn't matter. I think you can do it both ways, but we're going to choose to integrate e to the x because that doesn't change anything. Okay, so this is going to give us e to the x times sine of x. Now we're going to subtract off e to the x times the derivative of sine of x, which is cosine of x. And now we have a dx over here. Now can we integrate this? Well, this is basically the same problem. Of course, instead of sine of x, it's cosine of x, but we don't know how to do it. So we actually have to use integration by parts a second time over here. So let's just go ahead and take this and integrate it over here on the side. We're going to use the same logic. We're going to do this. Well, I'll just rewrite it. E to the x cosine of x dx. E to the x, now that's the integration of e to the x. So we're going to keep cosine of x here. And now we do the subtraction of e to the x times the derivative of cosine of x, which is negative sine x. Remember the negative, so we're just going to switch this to a positive. And now we plug this back in over here. So our initial expression, which is e to the x sine of x dx, is equal to nothing but e to the x sine x minus, what do we have here, minus e to the x cosine of x minus the integral of e to the x sine of x dx, right? And I mean, if you continue doing it, you'd never get anywhere. If you just took this derivative, it would be circular. But because it's the same thing as this, we can just add them up. So now we get 2 times the integral of e to the x sine x dx. Now it's just algebra from here. This is going to be equal to e to the x times sine x minus cosine x. And to finish it off, well, all we have to do is divide by 2, and we'll get a final answer of the integral of e to the x sine x dx is equal to e to the x times sine of x minus cosine of x over 2. And feel free to actually go ahead and try this out for yourself, see what answer you get, and you will indeed get the same. When you take the derivative of this, you will get e to the x sine of x. Hope this helps.